So in this lesson, we're going to learn about making two-column proofs, but we're going to kind of work our way up to it. So in order to make a proof, you're going to have reasons for the things that you're saying are true. And these properties of equality are some of the reasons that we can use to say things are true. So what's here is important, and you're going to want to have it in your notes. So take a minute, pause the video, write it down. Because we're going to use these things, and most of them are things you've seen before, but you might not know to call this the addition property. You certainly would know that it's true if A equals B, then A plus some number C is the same as B plus some number C, because A and B are the same, right? So this is just fairly straightforward algebra stuff that you've known, but now we're going to be calling that the addition property of equality. There's also subtraction property of equality, where if you take the same number away from two numbers that are equal, then those differences are equal. Multiplication, you have two numbers that are the same, you multiply them by some number, they're still the same. And division, you take two numbers that are the same and you divide them by some not zero number, they'll still be the same. But these other ones might be new. So this reflexive, symmetric, and transitive properties, those are new, most likely, things you have not seen before. The reflexive property might seem kind of simple, silly, A equals A, but that if you don't know to call that the reflexive property, it can become a difficult thing to explain. So it will be very useful to be able to say reflexive property. The symmetric property just means that this equality goes both ways. If A equals B, then B equals A. And so we call that the symmetric property. And then the transitive property, if A equals B, this one's kind of neat. If A equals B and B equals C, then A equals C, right? Because they're both equal to B, so they must be the same. All right, and then finally we have the substitution property. If A equals B, then B can replace A in any expression. Okay, so we're going to use these things in order to do our two-column proof. So before you move on, make sure you have them written down. So let's look at an example of what I would mean when I say that we're going to use those things in order to do two-column proofs. So we'll start by looking at this example of finding the value of x. And we're going to write our steps down and we're going to justify each step. All right, I just popped our properties in here so that we can look at them while we think about this. So we have to figure out x. So the first thing that I'm going to do is I'm going to note that angle AOM and angle MOC are supplementary, which means they add up to 180 degrees. And my reason for that is that any angles they form a linear pair. Any angles that form a linear pair are supplementary. Okay, so you might recall from the last quarter when you took geometry that supplementary is our word for adds up to 180. If they add up to 90, we call them complementary. All right. So the next thing I'm going to do is I'll write that down. I'll write down angle AOM plus angle, the measure of angle here. The measure of angle AOM plus the measure of angle MOC equals 180. All right. I know that because I said of what I said up here. This is the definition of supplementary. All right. The next thing I'm going to do is I'm going to use the substitution property. So substitution property says if two things are the same, I can replace them. So the measure of angle AOM, so here we're going to use substitution property. And let me draw in just lightly here. You might see how this is leading to two-column proofs. So the substitution property lets me say that angle AOM is actually 2x plus 30 plus the measure of angle MOC is x. Okay, so before, when we were doing a problem of this, we might have jumped to this step right away. And that's fine, you can get the answer that way. But now we're working on formalizing how do you prove something. And we're not just doing this work for ourselves. We're doing this work, like the point of the work is that somebody else can read it and understand why you're saying what you're saying is true. And so that's kind of the idea of proof, is like taking this, just like, going from just solving a problem for yourself to actually solving it in very explicit ways so that other people can also tell that it's true. So now we're going to use just combining like terms to get this to look a little nicer. Combine like terms. So here I can combine my x's, so I get 3x plus 30 equals 180. And the next thing we're going to do is something you're familiar with. We're going to figure out x, we're going to subtract the 30 on both sides, right? So this is something that we all know to do in algebra. But now that we're doing this in geometry, really what we're saying here is that 3x plus 30 minus 30 is, well, let me take that a step back. What we're saying is if 3x plus 30 equals 180, then 3x plus 30 minus 30 equals 180 minus 30. And that is actually the subtraction property of equality here. So over here, I'm going to write that 3x equals 150. And my reason for that is the subtraction property of equality, or just the subtraction property. I made my thing smaller, so hopefully I can fit all this in. These do tend to get long and they take time, so be patient. And then the next thing I would do is I divide by 3 on both sides, or actually the last thing I would do is I divide by 3 on both sides. And that divided by 3 on both sides, now we're going to actually call that the division property. Because we are really invoking this this idea that if two things are equal, like 3x and 150, then you can divide them both by the same thing and they'll still be equal. And finally, we find out that x equals 50. And that is our final answer. So technically, we should have lines in here. So I got the 3x equals 150 using the subtraction property, and I finally got x equals 50 using the division property. Okay, so on the next slide, you're going to try a similar thing. Make sure you write down every step and your justification for those steps. Having these properties in your notes is going to be crucial. All right, good luck with that. And once you're done, we'll look at the next kind of problem.